Good morning. Dzień dobry to everyone. I've spent like 5 months, 10 years ago as an Erasmus student in Poland. I'm kind of very into Polish people and Polish developers that I was working with. And I wish I really could be there with you in an on-site event, but this year we need to make it on our living rooms. And today I'm going to talk about serverless observability, and I'm going to try sharing my experience and expertise with you. So before coming up that, let's talk about like what makes observability special. Is this kind of a new buzzword, or is it like something real? So I would say the second one. Observability is about unknowns. So when you do monitoring, what you are actually doing is you are just trying to understand if the failures that you would expect is actually is happening in production or not. And when you do test your applications, what you do is this: you are just verifying that your assumptions are correct. But when you make your system observable, what you do is this: you just make your systems capable of answering questions when there's a problem. So as I said, like this kind of an any kind of issues matrix in a systems, and monitoring only helps with known knowns. As I said, like what can go wrong, and how you would understand this. But for unknowns, you need to have observability in place. And let's make kind of a like one last comparison between observability and monitoring. And first of all, like observability and monitoring differs a lot with the definition itself. So observability is a state, while monitoring is an activity. Observability is the state of your system, while monitoring is your activity. So with observability, you just make some activity again, but this activity will make your systems to answer some questions when you ask it. But with monitoring, it just gives you answers for the questions that is previously written. And with observability, you get the application level metrics, traces, and logs. But like with monitoring, you mostly look at the infrastructure level metrics, for example, CPU usage or whatever. And observability is kind of a lot closer to DevOps principle, while monitoring is somehow old school monitoring principle. So we are like in this talk, we are going to talk about, is observability possible in serverless? So we have logs here, we have metrics here from both CloudWatch, and we have X-ray, which shows us distributed tracing. But is it actually possible in serverless with the native tools? There are some challenges with the native tools. Like, so, for example, they are not very integrated with each other. Then AWS is resolving these issues day by day, but still there are some problems. And I'm coming across many companies who wants to build their own observability systems for their serverless architecture, which I try to prove that's not very suitable for themselves, especially for serverless applications. But let's see what challenges we have in observability. So since you don't have any access to the underlying infrastructure, you cannot actually install an agent that asynchronously gathers information out of these serverless invocations. And what you have to do is just like you set up a runtime agent which generates and gathers and sends the insights that it was gathering during the invocation time. So this means overhead. And overhead is, as I said, like gathering intelligence. You are asking that, hey, how long, like let's say, a database query takes, and you are just like measuring this should be acceptable. So it should be less than a millisecond. But transporting it to where necessary. So you just like gather this information. Now you need to ship them to somewhere else, for example, to your Elasticsearch database, to your relational database or whatever. And most probably you will need to make a HTTP connection. So this will add a really big amount of overhead. And even if you can just do this for one function, you need to understand the whole your architecture is in a holistic way, and because everything is event driven and distributed. Now, before I jump to like the rest of the presentation, I think it's time to actually talk about myself. And as you see, you see a kind of a younger and a kind of a less fat version of me. I'm Emrah Samdan. I was a developer before I transitioned into a product management job, and I now become a product manager for more than 3 years. And I'm the VP of product for Thunder Serverless Observability product. And I am an organizer committee for ServerlessDays Istanbul and ServerlessDays Virtual. And if you don't know about ServerlessDays Virtual, it's the first attempt to make a global virtual event for ServerlessDays. So, you know, ServerlessDays Warsaw is also virtual in these days, but like ServerlessDays Virtual will always stay virtual, and will make serverless knowledge accessible by anyone. This is the aim, even after the pandemic. And I very recently announced as the AWS community builders. And I'm actually very excited about being one of the AWS community builders and just sharing my knowledge with the community. So let me continue with the agenda of rest of the talk today. So I will talk about why serverless observability is actually very crucial. And I will then talk about what 3 pillars of observability means for serverless. And I will talk about observability best practices at serverless. And I will make an analogy between Maslow's hierarchy of needs with hierarchy of observability needs. It will be fun. So let's talk about why we come to that point. So, you know, at 19s, there were physical servers. You were just like making the room cool, you know, just to make sure that your servers are in the good form. And in the 2000s, now we have the virtual servers that we can rent, or we can just like put on our own machines. And then after that, in 2010s, like we have cloud computing becomes widely available for everyone. Now you can put these virtual servers on cloud and rent them by hour or whatever. Now we have serverless. In this way, as you know, we are just like renting the memory and the time. So we are not managing the underlying infrastructure. We are not managing the scalability. We are not managing the reliability of the servers. But what we are focusing on is instead is our own application logic. So this serverless enabled many people to put their focus on what really matters, just like to differentiate themselves with respect to their competitors. But as you know, serverless actually brings up some challenges, because, you know, when you first started serverless, you're kind of a small Pokemon. You know, you just get a request from an API gateway call, and you just write the result to somewhere else. And after a while, you start to build some event-driven architecture. Your application writes something to SNS, and it notifies 2 other functions, and those 2 are doing something else. And this is, you know, believe me, this is the correct way of doing this. And after a while, you will have several different event-driven serverless apps which are talking to each other, again with serverless services. So after that, we are calling this a Charizard. So when there is a problem in this Charizard, how would you understand first what is the problem? What's the impact to the other rest of the system? What's the impact to the other customers? So this is actually a very hard problem that you may face when you build a pure serverless application. Let's talk about the observability pillars before we jump into serverless observability discussion. So serverless observability pillars are traces, metrics, and logs. You know, traces are showing that how long and how these operations are taking. So you can say that service A started this operation at time T, service B, and it just finished this operation at time T plus 10, and writes some results to some queue, and service B consumes this queue and do something at T plus 15, you know, and it ends in T plus 25, and so on. So in order to understand this flow, you need to have traces, which is called also distributed tracing. And this shows you a full life cycle of what happened in the application. And metrics, you know, like there are like everything can be regarded as metrics, the CPU metrics, memory metrics, application level metrics, how many times my application got invoked, how many times it gets results, and so on. And the business level metrics, like how many, if for an e-commerce application, how many times the customers add an item to the cart, and so on. And the most ancient and the most primitive and most friendly way of understanding systems is logs, because everyone is accustomed to check the logs, dig the logs when it is needed. And we claim, and actually when I say we, I'm not like meaning my company or whatever I'm meaning the observability professionals. We believe that like when you lack one of these, actually you are lacking your base. So you should have all of these three on your hand before you build something on top of that. So you can build like a very fancy visualization. You can run machine learning algorithms and you can generate some other insights. You can set up alerts, but you should have all three at once. That's the rule actually. Let's talk about observability best practices in serverless now. So let's start with logging. So when you are logging something, you just don't like, you may think that in a lazy way, as I usually do, you can just like print logs. Hey, I am here. Hey, code is here. Hey, this is the value of this variable. Believe me that this will be a bigger headache for you in the future. For this reason, you need to actually have a structured logging mechanism which will save your life when you face the problem. And if you can automate logging with some middleware libraries, it will be even better. And as I say, like you need to then ingest these logs to some storage, and you need to have some sort of indexing mechanism so you can search the logs better. And talking about CloudWatch, if you don't retire your logs, you can face a problematic bill, which can cause a kind of sadness for you. Hope not. So let's switch to metrics. So for metrics, like there are some critical metrics which were not supposed to be critical for non-serverless architectures before. So memory usage. So in a limited memory of application, so you need to keep a close eye on memory usage, because if the memory usage goes over your allocated limit, you will have an out of memory error, and this will cause a problem for you. And timeouts, like again, you have also a limited time for your Lambda application, and if you don't put your focus on timeouts while watching, like the duration, you can have timeout problems. And concurrent executions, like although it is pretty high, but there's still a concurrency limit which is global to any AWS account on AWS, and you can also set up your own concurrency limits to control the usage. And you need to have you need to check frequently, or you need to set up alerts on a number of concurrent executions on your serverless architecture. Then there are also application level metrics. So how many times my Lambda function just got invoked? How many times it just returned 4xx or 5xx errors? How many times it just had the cold start, or so on? And you may want to understand average duration and also P99. So you may want to understand how normally my application is behaving and what are the ups and downs of it. And there are business context metrics. So which can be called that, like how frequent an event happens. For example, you may want to understand how frequently your Lambda function emits an event type, which triggers another scenario in your system. So what is the values of specific variable? For example, for an IoT system, you may have this to understand what is the temperature that your device is measuring in your IoT system, and you may want to see the chart of it. And usually aggregate them into a single pane of glass. So let's come to the most tricky part of this presentation, the tracing. So serverless is event-driven and asynchronous. So as I say, service A writes something to SQS, and service B, Lambda A, writes something to SQS, and Lambda B reads from, consumes this message. And this happens asynchronously. How should we keep track of those? And it's when it is SQS, X-ray can help, but like sometimes it's third-party API, sometimes it's non-AWS services. How would you track this? And how would you actually correlate these traces with logs and metrics together? So in this execution, Lambda A did something, hey, here's a trace of it. But if we could know what are the logs of this trace, this would be great. And on top of that, if we could know what are the metrics of this trace, this would be even better. So distributed tracing is the answer to understand the distributed serverless applications, which are highly asynchronous and event-driven. But there are two issues, like how we are going to produce these traces and how we are going to visualize these traces. So for generating traces, as I said, X-ray helps, but still not sufficient. Because when it's for example, it is now not supporting the events over Kinesis or Firehose, and it's just like very not very recently, but like there were even not support for SQS for a long while, and it is still coming behind. And non-AWS services will always stay as a problem. And in this case, you can think of, hey, then like sadly, I should instrument every service myself. This is actually like, you will inject relevant data to spans to make them more meaningful. You should inject the request and response payload to the like instrumentation. You should inject the HTTP status code. You should inject correlation IDs so that you can link them together after while you are visualizing them. And for those, there are some open tracing solutions. Like open tracing is about to be the solution that is being used for this. And now open telemetry is kind of a newer standard, which will be defining more terms in terms of how to generate traces. Let's talk about like, what is this? This is something kind of looks like a very buzzword, but I will explain what it is actually. So, remember this knowns chart, and in this way, in order to understand unknown unknowns, you should actually instrument your applications manually. You should generate spans, you should add new information, just to let you ask questions when there's a problem. And I'm saying this as a VP of product in an observability company. No observability tool can understand your system automatically. So like even we are generating many automated traces. We are generating, we are instrumenting every service call that your application is doing. But at some part of the code, there are some code pieces which only can be understood like with the ones who wrote this code. So for this part of the applications, you should have observability in place to make it understandable after that. So which is like, you need to just instrument those parts of application as well. And we should not regard this as a replacement for test-driven development. Test-driven development is, as I said before, a verification of our previous assumptions. But observability-driven development is actually, hey, it's better I create a span here, and if I see it on my trace when there is a problem, I can understand the issue, whatever issue it is, in a better way. So this is actually not related with even the test-driven development. And this is actually very important. So if you think that, hey, I know what question I'm going to ask to my system, so this should not be your job. So if you are using Tundra, for example, you should ask this to us. Hey, I like this to be instrumented. I know what it is. Like, I like this service call to be instrumented. You are not instrumenting this. I'd like, some asynchronous calls that is done by Node.js to be instrumented. So we can do this, but we cannot know how long, let's say that, how we are going to instrument your application, which is doing a very custom logic. So you should instrument this yourself. And the manual instrumentation is required in these purposes. And there's also some problems, like how we are going to know that, like, what is your observability coverage? You know that with test-driven development, we know that we have something called test coverage. But like, how do you know that you are ready to answer any question when you instrument your applications? And it's very actually hard to accustom. So when you are building a new service, you will need to think about this. And you can't sample anything if you are doing manual instrumentation, because you must be worrying about like knowing this every time. So automated and manual instrumentation together is actually something good, but instead of this, we recommend using observability service and put your focus on the value. And use tagging in this observability service to embed your business context into traces. These tags can be your user IDs or any kind of entity identifiers, event types, your custom KPIs, like how many times this code is working or not. And try to avoid manual instrumentation as much as you can, because you are polluting your code with instrumentation code, and when someone enters your team, it's actually one another item to onboard a new engineer. So let's come to visualizing the traces part. So like in a serverless architectures, remember the Charizard, like let's say that there are 4 important metrics for each function, and which is like invocation count, which is like error count, durations, concurrency metrics, and so on. If you would look at these, if you would look at these Lambda functions using these charts, you will need to have hundreds of charts to understand it. So that's why, like, understanding the performance of serverless, or if we can generalize this to an event-driven applications, is actually not quite possible using, old school charts. You need to have somehow like time-sensitive flow diagrams, which is called trace diagrams or trace charts. There are some open source solutions for that, but you need to do some modification to your data to make it compatible with this, and it becomes another thing to maintain. And how would you actually set up alerts on top of your traces and so on? And Jaeger and Zipkin does this, but as I said, these are solutions which are open source, developed by great folks, but still it puts you another burden to you. So we say, as Sandra said, that you don't need to try to build it yourself, because we believe that serverless is meant to be focusing on the value at the first place. So why don't you just focus on the value and don't try to build an observability solution for yourself. Like, for example, let's say that you want to build an integration for your application, then you will need to think about like how I'm going to instrument this service and so on. Like, let other people think about this. And you should take advantage of automated setup and zero maintenance. And manual instrumentation is problematic. Manual visualization is even more problematic. So, like, I'm not saying that don't use manual instrumentation, but I'm saying that use it when it is only needed. So that brings me to how we are seeing the observability needs in the serverless architecture as a hierarchy. So in a normal system, you have your whole system, and you have some transactions happening here, but these transactions are happening over and over again. So we can group them as business flows, and we can say that, hey, this is the transaction of like saving one user, and this saving a user business flow happens, let's say, 100 times a day. So this is business flows. And I already explained transactions. This is like distributed transactions, which includes like several Lambda functions and several serverless resources. And in this way, some specific action is carried out. And functions are the compute of these transactions. So there are like, in a transaction of, let's say, an user say you just get a request from API gateway to Lambda function A, it just notifies to other services to send an email to this user, and Lambda B gets notified and send an email to this user asynchronously. So Lambda A and Lambda B is the part of that transaction. And even in this code, like in Lambda functions, there are some code blocks that you want to understand by debugging. So for each kind of level in the pyramid, we have a solution, that can help this. So for example, let's look at the architecture overview. So instead of looking at charts, it is better to look at such a view. So when we look at this picture, we suddenly and just like very easily see that there's a problem with Redis, and you can see that all the edges going to Redis is red, and here you can understand that, hey, there's a problem with Redis. I should check this. Maybe I should check the Redis first before I check the applications. And let's talk about business flows. Let's say we see deleting a team business flow here. So we see that how many times deleting a team is happening, and what are the resources here, and how many times it's actually having problems here. And in this way, you can actually catch the security breaches. Let's say that you have a third-party API which you are using, and this third-party API is making some malicious behavior. And in this way, it's taking your data out. So when it starts in this way, this will actually create another business workflow for you, because this will add another node to your diagram over here. And in this way, you can see that, hey, this is not deleting a team, this is something else. And you can see the security breach. And when you can show such diagrams to your new engineers, actually it will be quite easier to onboard them. And in this way, you can also see your high-level KPIs. So you see how many times a team is deleted. Like in order to ask these questions, you will normally maybe take some other reports, but business flows can show you like how many times an operation is happening. And transactions as a part of business flows, and transactions are calculated or drawn by distributed tracing. So in this example, a request comes to save a team, and this like goes back to Redis if team is already existing, and after that it writes the team to Dynamo, and it's notifying another Lambda function just to send notification to some people through SNS, and so on and so forth. So, but with this transactional view, you can see there's a problem with Redis, and you can see there's some kind of a slowdown here. So in this way, you can understand what's going on in your serverless distributed architecture. And invocations is like what happens in the invocation. So you can understand, you can just understand it by just checking the logs, but you can also understand this by checking on what happened in your application line by line. I'm coming to that place. Normally, when you are debugging an application, you can just plug the debugger in and you can understand what's happening. But with serverless, you see the problem. You dig the logs to understand. You put a new logs in place and understand what's going on here. If you're lucky enough to understand the issue, you actually deploy your solution with your fix. See the result by again checking the logs. If you couldn't fix it, you should again see another problem, and you should maybe dig the logs once again. This is kind of a very, long turnaround time, and this is actually very inefficient use of developer time, and it is actually very, very harmful for developer productivity. We have something called post-execution debugging at Tundra, which lets you understand what's going on in your application line by line, even after it is completed. So you can see the changes in local variables, you can see what's going on in the environment, and so on. And we also have something called real-time debugging for AWS Lambda environments. So we have a VS Code plugin and IntelliJ IDEA plugin for Node.js, Java, and Python. And when you do this, when your application is running on the cloud, your IDE is actually taking this application, and you see what's happening in your application as if you were debugging a local application. You can play with the local variables. You can change the local variables. You can step over your breakpoints and see what's going on. So let's talk about the key takeaways from that presentation. Serverless observability is not an after production issue. So you should have the observability tool in place before you go live with your product. So you should have all pillars of observability, and they should be aggregated in order to be successful to maintaining the operational excellence. You know, you should automate everything if possible, but you should be also, you know, ready to ask your own questions using observability-driven development. And you should, instead of just looking at one function, you should change the way you monitor your system and look beyond functions and have a more holistic way of understanding applications. And you should look at like how serverless transactions are doing by checking the distributed tracing. And debugging is also very important in serverless because logs, when it comes to just understand one invocation, is mostly not enough. Thanks a lot for your time. And I'm actually very glad to be meeting with you. And do widzenia.